Okay, we're looking at maps now. Let's start with the simplest one, which are hash maps. And I'll just do a main. Come on. All right, so let's okay, so let's just because it makes it easy to put a bunch of stuff in. We'll have our keys be integers and our values be doubles. You have to import all these. Again, I strongly recommend, like there was, in the early days of Java, you would sometimes see stuff like this. And that's not recommended these days. It's actually recommended to explicitly import each individual one like this. Question of style, but especially since if I right-click and say fix imports, it's going to go and find them. So, and it makes it clear where you're getting stuff from. All right, so let's generate a bunch of random ones. So our way of doing that here is to use the Java random one. When we do our simulation next quarter, we're going to use a different way of generating random numbers, but that's later. So let's just put a bunch of stuff in here. Oh, well, let's just do 10. Okay, so I'm going to put my index. It's trying to give me an RNG. Next, let's put Gaussians in. Okay, so and now here's if I wanted to print this, if I just print this out, it's gonna, well, let's just print it out and see what happens. It's gonna not look very pretty. Okay, so we have, it just prints everything out on one line, but then now notice that a couple things. For our sets and lists, it would print things with a square bracket. For maps, it prints them with a curly brace. Who cares? But and then notice what it does is it gives you the key and the value. Now in this particular case, if you will notice, it's actually kind of kept them in order for some reason. But because this is because I made it a tree map. Let's see what happens if I don't. Okay, it's still, yeah. See, this is a function of how it's hashing things under the hood. For just a few of the integers, see the keys are these integers, and the hashing function for just a handful of integers is just going to kind of keep them like this. If I were to add a whole bunch more, then they would start to get mixed up. Okay, but now I think they start to get mixed up. Well, regardless, that's not a good way to print a whole bunch of stuff. A better way would be, okay, I can use the for each, and here's how to do that. So my okay, so each map has a method called keySet, and that keySet return. Well, guess what the keySet returns? We can actually see what it does if we it returns a set view of the keys contained in this map. All right. And then I get it. Okay, so here's, if you remember in an array, how do we have this special syntax. But what this says is get the value at index 3. For maps, again, the maps being first-class objects, they have a method called get. And what get does is get gives me what the value is for a particular key. And so now we've seen a little bit of introduction to this syntax here. So here's how this would work. Okay, well, okay, so here what I'm doing is I'm just going to print out a line from the key to the value like that. Since there are 100 of them, okay, so here the hashing function is keeping things in nice order. All right, however, tell you what, let's mix that up a little bit. And over here, let's put a random int in and see what that does. Okay, so now we see, if for some reason, again, that the hashing function still seems to be keeping them in this order, but because it's a hash map and just declared to be a map, you can't count on that. I can't count on any of that. And in fact, yeah. All right, so
you're now picking a random key number to put in.
Yeah, no, I am. In fact, you notice that it kind of skips some.
Okay.
Those are cases where it's kind of duplicate. What it is the hashing function, which I mean, again, I have no idea what the hashing function is for this, but what it's doing is it seems to be keeping the numbers in order here. In the past, that wasn't happening so much. That can't be counted on for a hash map. For a tree map, it can be. So here's a. Okay, so here's number of things going on here. Let's deconstruct that. Okay, first of all. Oh, question. Yes.
I'm sorry. Why isn't this with the number 99 not mentioned?
Ah, great question. Why is there no 99?
Because I went through 100 times. What was your name?
One or two times.
One or two times.
Yeah, so I generated a random number between 0 and 100, and it never generated that. But Terry, let's spread it out a little more. Okay, there we go. So, all right. So now when I'm generating values between 0 and 10,000, okay, I'm getting a lot more of a spread, and so the hashing function is now having to work a little harder. See, when it was just kind of having a bunch of integers that are all close together, it was able to kind of hash them pretty well. But here, it's working really hard, and then notice the order is gone, and the numbers are now all over the place. Yeah. So for a hash map, you use that in a situation where I don't care about the order, but I want to be able to get a particular value. Okay, so in those situations, use a hash map. Now, I want to deconstruct this this little bit here, we're printing it out because there are a number of things going on here. The first thing, see, the values key set is a set, and we're using the for each syntax of looping through the set. And you use that when you want to step through every item in the set. Just as for an array, if you want to step through every single item, and I don't care about the index, then I want to do that. Here, I'm actually stepping through the index, and I'm going to step through the entire thing. Okay, so that's one thing. The key set contains integers, capital I. They contain integer objects, not primitives. And yet, I'm pulling this out of this key set, and I'm declaring it to be an int, lowercase. That's auto-boxing at work. Just as up here, when I was putting them in, actually in both cases, RNG next int is a lowercase, it's a primitive int. But when I go to put it in, auto-boxing says, okay, you're trying to put an int in, and I want an integer capital I, so I'm going to wrap that up in a capital I integer before I put it in. Likewise, the value, this is a double, lowercase d, a primitive double, and it's saying, okay, is this compatible with what I need? And what I need is an object double. It's a primitive double, so I'm going to wrap it up in an object double, and then I'll put it in. Okay, but here I'm taking it out, and so when I take it out, this is going to return an integer object, and it says, oh, I see you're putting that into a lowercase int, and so I will unwrap it for you and put it in there. So whenever there's that context. Likewise here, the values are double, capital D, not primitives, but I'm putting it into a primitive value. So the context that I'm using that is of a primitive, and so it uses auto-boxing to say, okay, I'm going to turn that into one of these guys for you. Now there's a subtle gotcha here, and that subtle gotcha when you're auto-boxing is that if I'm trying to get something that isn't there, then what does it do? So for example, here I'm only generating between 1 and 10,000, and so what if I try to get 10,001? Okay, so these guys, actually 10,000 couldn't be in there either. So let's live close to the edge. All right, so what's going to happen? See, when I try to do that to an array, because an array has a fixed size, if I try to get, and this is what drives everybody crazy. If here I have an array of size n, give me the nth element. That's a perfectly reasonable request. The nth element does not exist. The element at index n, the nth element has index n minus 1. And if that's not insane, I don't know what is. But nevertheless, if I try to ask an array for something that's out of its bounds, then I get an array out of bounds exception. We've seen that. Now here, likewise, when you're executing this, you have no idea whether or not that's a legitimate key. You know, I mean, it's a legitimate key because it's an integer. So it ought to, you know, the compiler's happy. So see, if I try to get a, if I try to do, it's more forgiving. So okay, forget that. All right. So now, what should happen here? What do you suppose is going to happen? It's going to return null. So let's. All right, so let's see, and indeed it returns null. Okay, so unlike unlike an array, so with an array, I'm going to get an array index out of bounds exception because they're so anal about it. Here, it's saying, okay, no, you want to get element with index 10,000? No problem. I don't got one, but I'm going to give you a null. Okay, so just just know that. Here's a subtle bug, or I mean subtle error that you're going to get. What do you suppose is going to happen if I do this? See, now I had no problem doing it up here, but what do you suppose is going to happen when I do it here? Well, let's see. Okay, null pointer exception. Okay, why a null pointer exception? Because what it's doing is it's getting, okay, first it's auto boxing 10,000 into an integer. It's saying, okay, that's a legitimate key. Do I have an item with a key of 10,000? Nope, I'm going to return null. So it returns null, but then auto boxing says, oh, I see you're trying to put that into a primitive, so I'm going to unbox that for you. So now how do you, when I say unbox it, how do you do that? Well, you take the, in this case, the double object, and you invoke a method on it to extract that. In fact, that method, we can actually use here. We can see what that is. What that method is double value. Where is it here? Double value. So this is the double object, and it has an instance variable called value. And the way that unboxing works is it invokes double value on the double. But what happens if you invoke an instance method on an object whose value is null? You get a null pointer exception. Okay, so this is the reason I'm pointing this out is that once you get used to auto boxing, it's very convenient, but you have to be aware of the fact that if I get something and it happens to be null, and I'm auto boxing it under the hood, then I'm going to get this null pointer exception. So a better way to do it would be something like, well, to do it yourself. In other words, okay, do it there, and then say if I'm not null, then do this. Oops. Okay, so here's how I unbox by hand, and I can sort of okay, so if, again, like when you're writing code, you want to be mindful of what can go wrong and try to trap as much as you can. So in this case, rather than having a null pointer exception, recognize the fact that what's coming out could be null, test it for that, and then unwrap it yourself in this particular case. So that's sort of one of the little gotchas about these maps is that they're much more forgiving than arrays are when it comes to saying, give me the item with this key. Yeah, with arrays, if I give it the wrong thing, it's going to get array index out of bounds exception, and that's a runtime exception, unfortunately, in this particular case, for the case of arrays, because they, well, for whatever reason, the compiler can't tell at that time, typically, that it's going to happen. Here, the exception that I may get is going to be a null pointer exception if I assume that the object that I'm trying to get is actually there. So if there's a mismatch between my expectation of what is going to be in there and what this is saying, it says unnecessary box. See, in this case, I can actually safely auto box it, what this is pointing out. And again, NetBeans is kind of nice about pointing these little things out. Again, in this case, it's safe to unbox, but only because I protected it by this. Because the only thing that can go wrong here is a null pointer exception. Okay, so that's an